Welcome everyone to Klara's webinar on Enterprise Certificate Management on FreeBSD, hosted by myself, Allan, Jude, and Kyle Evans, one of our senior software engineers. Kyle, do you want to introduce yourself?
Yeah, hi, I'm Kyle Evans. I've worked on certctl as well as a lot of Lua and bootloader stuff, and kind of just anything else that seems interesting at the time.
Yep, and so Kyle works with us here at Klara, with myself as the CTO, and we do enterprise FreeBSD and ZFS support and development. So today we're going to be talking about certctl, which is a tool for managing the trust chain of certificates on FreeBSD. So we'll start with a quick history of how certificates used to work on FreeBSD, why that was a problem, why we wanted to fix it, and then how we introduced certctl and how that works and how you can use it to manage your local trust store. And we'll also talk about when you don't want to trust certain things and what to do when things break down. So Klara, as I mentioned, is a FreeBSD and ZFS development and support company. If you need development done on FreeBSD or you would like support for FreeBSD or ZFS, you should reach out to us and we can get you hooked up with a subscription. But to get straight into what we're talking about today, the history of certificates on FreeBSD. So for as long as FreeBSD has supported SSL, FreeBSD as a project has used OpenSSL. But OpenSSL itself does not actually ship with any trusted certificates by default. OpenSSL is basically just the encryption algorithms and the tools around it, and they don't feel it's their place to dictate what should be trusted and what should not be. And the FreeBSD project itself has always had, its mantra has been tools, not policy. So it provides you all the tools to do what you want to do, but it doesn't tell you which way you should do it. You should do whatever you prefer. But that meant for a long time that the project didn't want to be in charge of deciding who you should trust and who you shouldn't. But this resulted in a very poor kind of out-of-the-box experience when using FreeBSD because you couldn't connect to any HTTPS websites, even just to download things to install them and so on. And having to go read the man page for the fetch command to find the environment variable to set to say it's okay that I don't trust that certificate kind of defeats the whole point of HTTPS anyway, and was just a bad experience. So what users would have to do is use the package system on FreeBSD and install Mozilla's CA root package that comes from their NSS product, their security tool. And that will provide this default list of trusted certificates, basically the same one that's built into the Mozilla Firefox browser and a bunch of other things like that. But the fact that that didn't come bundled as part of the system created a lot of problems for people and just meant that the system was not very useful when you just installed it. But why do these certificates matter? So when most people think of TLS, they know that that's encryption, and that encryption is mostly about privacy, making sure that somebody else can't read your messages or the content you're sending or you see your credit card number. But in this case, the most important part is actually about ensuring the identity of the remote host. The reason why the fetch utility wouldn't connect to GitHub, it would say, hey, GitHub presented a certificate that I don't trust. You probably don't want to connect to that. Because while it's great to have encryption for privacy, if you're sending an encrypted message to the wrong person and they have the keys to decrypt it, then you might as well not have encrypted it because now the wrong person is reading the message. So the most important job of TLS is actually about verifying the identity of the machine you're connecting to, that you're connecting to the real GitHub, not someone pretending to be GitHub. So when you download that chunk of code that you're about to install in your system, you know that it's the real code from the correct project, not some compromised version. Because like I said, encrypting traffic to an imposter doesn't actually provide you any privacy or security. So in order to verify the identity of a site like GitHub, that GitHub will present us with a certificate when we connect to it. And then that certificate will have been issued by a certificate authority. And the list of trusted certificate authorities is this bundle from Mozilla that wasn't built into FreeBSD before, and you had to install it as a package. So if we trust the certificate authority that's saying, yes, this is the real GitHub, not an imposter, then we'll accept the identity of that host and be able to connect. But if the certificate authority isn't on our trust list, or we have no trust list, then we'll refuse to communicate with it because it might be an imposter. And then, we can't download anything from GitHub, and that turns out not to be very useful. So your system has a list of certificate authorities that it trusts by default, or not, as the case was previously on FreeBSD. But you may need to add additional certificate authorities to that list based on your network. For example, if you have Windows or any Active Directory, or Security Intercept Appliances, or data exfiltration detection appliances, and so on, you may have additional certificates that you also need to trust. So if you have an Active Directory domain, it's going to have issued certificates for a lot of the different servers in your network, and you will want your host to actually trust those so that you're able to connect to them and communicate properly. So with the previous method, you got that from that Mozilla CA root package, but that provided basically a single file with all the certificates in it. And this proved really problematic when you were trying to add your own certificates to it. If you just installed the package and then modified that file that got installed, then next time you did a package upgrade, it was going to overwrite that file with a new one, and your locally added certificates would get undone. But if you tried to modify the package, it would get much more cumbersome, or it might mean that you don't update the modified version of the package as frequently as upstream does, and then you end up not getting the newer bundle, which means you might still trust an authority that's been revoked. So in the past, a couple of times, different certificate authorities have been untrusted by all of the browsers and just the general internet. Like when Symantec had their ability to issue certificates withdrawn, and so on. And so it's important to keep this list up to date. So in the New World Order, this is actually a directory full of symlinks, but I'll leave that a bit more for Kyle to explain.
So now we're going to talk about the certctl tool itself, which is kind of our solution to managing this kind of stuff. First, we'll look at the interface for it a little bit. Or no, first we'll talk about it, sorry. So we shipped the Mozilla bundle. We split the bundle that we're actually pulling from Mozilla into individual certificates into user share. certctl then acts as a bridge between this and OpenSSL. We have a list of trusted and untrusted directories that include places off in local base, so that you can customize that with your own custom packages, or you can install them manually outside of the base systems management, and then certctl will honor that as well. Generally, what it does is it, instead of having a whole, one single bundle file, it calculates a subject hash for each, which OpenSSL is looking for, and places them as symlinks into Etsy SSL certs, so that OpenSSL then just works as long as it's properly configured.
Yeah, the idea there is that when you go to fetch something from GitHub and it gets the certificate from GitHub and it says it was issued by this certificate authority, OpenSSL wouldn't be able to guess what the file name of that would be, but by basically taking the hash of the subject of that certificate and looking for a file with that name, it's able to find wherever we happen to have put that certificate.
And we have a concept of untrusted certificates that we'll get into a little bit more as we talk about the infrastructure involved. But the name is generally as it implies, that these are things that we don't really trust. So then we will talk about the interface a little bit.
Right, for untrusting, the point is that when we take the bundle from Mozilla, if there's something included in that bundle that you don't want to trust, by putting it in the untrusted directory, we will skip including it in the list of trusted ones when we refresh it.
So the user-facing parts of certctl are pretty straightforward. You have certctl rehash, which is arguably the most important part, but you're not going to actually be executing it all that much. It's necessary after you change the bundle. So when you add a new cert into a trusted directory, or if you remove it, or if you add another cert to an untrusted directory, then that requires a rehash in order to actually reflect the changes in etcssl. So rehash is the bridge between the system's trust store and OpenSSL. If, for instance, Mozilla trusts a certain authority that you do not necessarily, then we provide the untrust command that will make it untrusted. As Allan was explaining, this is how we make sure that we don't put that certificate into the trusted store. So it's still included in the base bundle, but then you're saying you don't trust it. So then when we rehash, we consult all these untrusted paths. And if it's not trusted by you, then that's the ultimate authority on it. It does not go in, it does not get trusted. And it doesn't modify the certificate, and it doesn't actually make any changes that OpenSSL is aware of. So it doesn't do anything as far as explicitly distrusting it. It's just, it's more of a loose, we don't trust this kind of concept. And then we have certctl trust, which is a little bit of a misnomer because that actually means don't untrust it. That's likely to get renamed in the future to reflect more accurately what it really does, because in reality, it just removes it from untrusted paths so that a subsequent rehash will then put it back into the trust store for OpenSSL to use, rather than being a convenient way to actually trust a new cert. So the functionality there might change a little bit as well going forward. There's room for improvement here for sure.
Yeah, but the idea is that if you just deleted the file from the directory full of files that FreeBSD ships with, the next time you upgrade, that file might come back. Whereas by putting it specifically in the untrusted directory, that means when we go through the list that you haven't modified from FreeBSD, we will say, oh, we should skip all the ones on the untrusted list.
Right. certctl is all about trying to promote you not trying to modify the base store, but rather providing you the infrastructure to make changes outside of the base store. Because like he said, we will collaborate on an upgrade, and that should be fine.
Yeah, part of the design behind it was we need to make sure that in the event that, say, some root certificate authority does get compromised and we need to revoke it on all FreeBSD machines, we can easily ship an errata for FreeBSD that will do that. But at the same time, we don't want to cause that to undo any settings people have deployed in their production, because we don't want, an important FreeBSD security update to break their setup.
So we have here kind of an example scenario. In this scenario, we were operating on a system around a network that has a local Active Directory. So in order to actually talk to the directory, then we needed LDAP-S, but the problem is that the domain is using its own certificate authority, which is actually great. That's generally what you want, but that's not necessarily good if it's not, cross-signed by something that's actually trusted by Mozilla. So in this case, we had to extract the public cert, or extract the cert from the domain and then add it to our local trust store. So here you can see we first create the local directory where this goes, which is something that in the future could be improved with a certctl command. We simply move the cert into the new directory and rehash. And then as you can see here, it lists the contents of the SSL store, and we have a symlink back to the cert that we just added. So that going forward, an LDAP search against the domain will actually work, rather than complaining about not being able to verify the certificate presented.
Yeah, one of the other cases outside of Active Directory where you end up using TLS this way is TLS Intercept Appliances. So these are basically something that lives on your network. And then as clients on your network try to connect out to the internet, this appliance wants to be able to view that traffic, whether that's to prevent sensitive data from being exfiltrated or just providing virus scanning or whatever the case may be. What these appliances end up doing is they'll make the connection out to, say, GitHub, and GitHub will present its certificate. And then the appliance will actually sign that certificate from the appliance itself. The appliance will have its own root certificate authority, and it will sign the GitHub certificate and pass that along to your machine when you connect. And this way, the appliance is able to basically be in the middle of the encryption going back and forth, and is able to scan what you're sending out to GitHub and what GitHub's sending back to you to make sure that you're not exfiltrating secrets, and that the thing you're downloading from GitHub isn't a known virus or malware or whatever. But in order for this to work, the operating system has to trust the root that's issued by this TLS Intercept appliance. And that's how it's supposed to work. But you need a simple way to be able to add trust for that appliance to your FreeBSD machines. And that's where certctl comes in. But sometimes, if you have a good version of one of these appliances, it will actually have two certificate authorities. One it will use on, so basically it will apply the same process where it has a trust store and will look at GitHub certificate and be like, okay, this is a legitimate certificate, and so I will sign it with my certificate authority and pass it on to the user. But if it encounters an untrusted certificate, like a self-signed certificate from a developer's homepage or something, then it should sign that certificate with a second certificate authority that it has, and that one should not be trusted by your FreeBSD machines, so that any sites that present invalid certificates continue to actually present as invalid to your users, whereas an appliance that just blindly resigns every certificate it sees with its certificate authority will basically promote those invalid certificates to valid ones, and that's usually not what you want. And so you want to make sure you're not trusting that second certificate from the appliance, so that you ensure that your users can still tell the difference between a trusted and an untrusted certificate. And then we have the times where all of this breaks down. So back in May of 2020, one of the root certificate authorities, AdTrust, reached the, I think, 20 years that it had been in the trust store, and the certificate expired. Normally, this wouldn't be that big of a deal, but it turns out that when they were issuing certificates in 2018 and 2019, the root authority that replaced AdTrust was still very new. And there were older devices, like older Android phones and like versions of Windows XP or whatever, that were old enough that their trust store didn't include the new certificate that would replace AdTrust. And so the certificates issued at the time were cross-signed, basically signed by both the old and the new root authority, so that any device that was too old would still trust the old certificate, but when that old certificate expired, the newer certificate authority would still provide a valid signature proving that GitHub was GitHub. And the same thing happened last month with Let's Encrypt. One of the roots that signs Let's Encrypt expired, but there was a second one, and the certificates were cross-signed so that as long as one of those two was still valid, it should work. But it turned out that a bug in older versions of OpenSSL and a bunch of other TLS libraries meant that as soon as they found one invalid certificate somewhere in the chain, they'd mark the entire chain as invalid. Whereas, there was actually two distinct paths, and there was a way to get, from the site certificate back to the root on a purely trusted path. But because of a bug in software, it meant that a bunch of these certificates were showing up as untrusted. And I know Kyle had some fun fixing that on FreeBSD for the code review tool, right?
Yeah, I ended up having to triage that down to an old bundle that was included with Arcanist that didn't include the new root at all. So then anyone, trying to actually interact with Fabricator was suddenly not able to submit reviews. And that,
Yeah,
that's very painful.
Yeah, like we were talking about, we were talking about old versions of Android and Windows XP, but it turns out that a lot of software assumes the operating system might not have the newest trust store, and so embeds its own. But it turns out if that software itself is out of date or has stopped being maintained, then it's bundling a trust store from years ago, and as certificates expire, while the certificate's cross-signed, the new certificate authority that cross-signed it isn't in the trust bundle, and then everything breaks down.
So that's all a good argument for centralizing your trust store process, and also for managing your own internal infrastructure properly. There's a number of challenges you face in both kinds of things, and by not running your own internal infrastructure has its own pitfalls. You can't really run internal hosts with self-signed certificates. It's impossible for internal users to distinguish trusted hosts from untrusted hosts, because if every certificate's self-signed, then suddenly how are they supposed to know which self-signs are valid? It's a lot easier for a malicious actor than replace one of your host certificates with their own self-signed, because, well, what's the difference?
Yeah, the last thing you want to do is train your users to ignore those security warnings. And it's gotten to the point now where the browsers have made it harder and harder to bypass those and connect anyway.
Yeah, and it's easier to compromise when there's just no known trust anchor. And certificates are only useful if they're trusted by all devices. Every endpoint needs to accept the certificate or it's not trusted. And you really don't want to rely on external entities for assigning trust to your internal hosts. That exposes internal host names to external entities, which is necessarily not compatible with people's security models. And in some cases, it relies on others' auditing procedures, which in a lot of cases, that's pretty important to be able to outline in excruciating detail exactly how your root certificates are being secured, so that you can prove trust in internal hosts.
Yeah, like a lot of certificate authorities now have to take part in the transparency mechanisms, where they have to publish the list of every certificate they issue so that others can audit that and make sure that we don't end up with DigiTrust issuing certificates for Google.com to bad actors, like has happened in the past. But that means that if you try to get a certificate issued for an internal host name for your Active Directory or something, that ends up getting exposed to the public because of the transparency requirements, and that might not work with your security model. So if you're interested in deploying certctl, it's built into modern versions of FreeBSD, but if you need assistance with that, then reach out to us, contact@klarasystems.com. And one of our FreeBSD support subscriptions can help you make sure that you keep on top of this, and then we can help you build the kind of infrastructure you need to secure your network. Do we have any questions? I was gonna, yes, Mike, go ahead.
Is the audio working? You can hear me okay?
Okay.
Yeah, one thing I've been looking at, thanks for that talk, that was great, was sort of extending certificate management down to the SSH level. Like we've been looking at, I know the certificates in SSH are not at all X509, but have you guys looked at sort of extending out certctl and some of the native FreeBSD tools to create a a PKI hierarchy for SSH certificate management, or is everyone using tools like Small Step and things like that?
That's a good question. I've not actually ever considered using certctl for SSH certificates, and I can see how having an infrastructure for that would be useful.
Yeah, I'm not aware of any ongoing work to do that. I mean, that'd definitely be a good use case for it too.
Yeah, and just generalizing it to cover everything would actually be, that's a good idea.
Yeah, certificates sort of help with that first use issue, right? You know, you're logging into a host, you don't know, all right, is this the proper host key hash and whatnot? But if you're using certificates, at least you know that, oh, okay, I'm connecting to something that was signed.
Yeah, and I just saw maybe 2 days ago the pull request into Git to make it support signing commits with SSH certificates as well. And
Oh,
so
okay.
there's a broader adoption for the concept of SSH certificates now. So I think that's a good idea.
Thanks.
And then I see Adam in chat just asked about how to import your own certificate into the Trust Store. We have the example slide here, but basically by copying it to the user local share certs directory and running certctl rehash, it will then take all the certificates from the FreeBSD root bundle, remove any that you've untrusted, add any of your local certs, and then regenerate the hash list that OpenSSL refers to, and it will now include your trusted cert, or the cert you wanted to add to the bundle. And importantly, it will remember that cert as you upgrade your system, and what's included in the root bundle changes. It will always regenerate and include the certificates you've added to that directory. Any other questions? Well, thank you for attending. I'm just going to give people another minute in case there are any more questions. Okay. Thanks everyone for coming.
Yes.